Link. There is James. There is no link for today. It is a PowerPoint instead of Nearpod, so there's no link. Oh, well, is there any link that you're referring to? All right, let's begin today. All right, a very good day to everyone. Welcome to the last lesson of We Love Science series. Today's topic we're going to talk about is sound. All right, have you ever wondered how do we hear sound? Or what makes us so special that we can differentiate sound about high pitch, low pitch? Like for example, if you heard of people saying low pitch, how do you differentiate low, high, or medium? Well, all these things we're going to find out today lessons. So the objective for today is to describe the production of sound by vibrating sources and describe the longitudinal nature of sound wave and state the approximate range of audible frequency for a healthy human ear, 20 hertz to 20,000 hertz, and show an understanding of the term ultrasound. And also, last but not least, we'll be looking through the loudness and the pitch of sound wave to amplitude and frequency. All right, and echo. So, what is sound? Sound is a series of wave or sound wave caused by vibrations. If you were to put your finger at your throat here, as you speak now, you feel that your throat here is vibrating. What I am talking now, the words that you heard me saying, is being produced by this particular thing here that's vibrating now as I speak. All right. So sound is a series of waves that's caused by vibrations. All right. When a drum is struck, the skin vibrates backwards and forwards very quickly and sending sound waves through the air to your ears. That's how you hear the drum sound. All right. Next. Sound wave travel as a series of compressions and refractions through the air. All right. They are called the longitudinal longitudinal waves. All right. All right. Some example is to look at this wave. All right. This wave is something like the spring, whereby the sources move left and right and vibrate here, and the energy will transport from this side, the source, to the ear, which will tell you is it high pitch or low pitch. Just like someone clapping hand now, you hear the clapping hands. The source is the clapping of hands that vibrated, and the sound waves travel through the air that reach your ears, and your brain will pick up the signal as it is a clapping sound. All right. If the sound wave is closer to each other, it's called compression. If the sound wave is further apart from each other, it's called rarefactions. All right. So longitudinal waves, all right, is basically vibrating backwards and forwards. And a different section, as shown in here, is called compression and rarefaction. All right. So how sounds are made? All right. As we spoken just now, as we mentioned just now, sounds is produced when something vibrates. Just like when we are talking, our throat here, the Adam apple vibrates. All right. As an object vibrates, it gives energy to the particles of matters around it. Sound is a longitudinal waves, and it moves with a series of compressions and rarefactions. All right. So anything that vibrates produce sound. When you speak, your vocal cords vibrate. All right. So the air basically moves backwards and forwards. A radio will not work in outer space. Or whatever sound that you have think of, if even you play a drum in space, there won't be any sound because there's no medium for the sound to travel through. All right. So you need something as a medium for the sound to travel. So it needs air, water, and so on for sound waves to travel through the respective ears or respective devices. So a radio will not work in outer space because there is no mediums for sound to travel. All right. Next. So the speed of sound. The speed of sound is determined by the temperature, elasticity, and the density of the medium. Sound travels slower in lower temperature. All right. Sound will travel slower when you are in a lower temperature, whereas sound will travel faster in the highest temperature. The average speed of sound in the air is 340 meters per second. All right. Next. This is some of the example of the speed that is that for sound to travel through air, helium, water, or steel. So when a sound traveling through the air, like I'm talking now, I'm talking to the air, it's traveling at a speed of 343 meters per second. If the air is helium, the sound will travel 972. That's why when you hear someone talking after breathing in helium, right, the sound pitch will get higher. All right, for water is 1005, and for steel is 5600. All right. So sound can actually travel through any mediums. All right. Greatest speed in solid, slowest speed in gas. The fastest is in more elastic mediums, whereas solid are more elastic. Then we have in terms of material, right? The more denser the material is, the slower the wave travels. All right. So these are all the instruments that produce sound. So as mentioned earlier, sound waves are longitudinal waves, and it needs a medium to travel through, and they cannot travel through a vacuum. So no sound can travel in a vacuum or in outer space. Sound waves can travel through solid, liquid, or and gases. All right. So let's carry on. All right. As we know that this sound wave is a wave, and the motion is basically vibrating up and back and forwards. So all these are called the wavelength. All right. So wave in the air can't really be transverse because the atoms and molecules are not bound together. So therefore, air molecules can really only bump into each other. Just imagine that you have people in a crowded station with hands in the pocket, pushing through the crowd to send a wave of compression into the crowd in the direction of push. Jerking people back and forward, sideways, or over several meters will not propagate to the crowd. But if everyone held hands, this transverse motion will propagate into the crowd. So this is a simple scenario for the respective how do I picture this sound wave? All right. Next, when two sound waves are present, the superposition leads to interference. by this, right, we mean, right, constructive and destructive addition. So two similar frequency produce beats, spend a little while in phrase, a little while out of phrase. Result of beating is of the sound amplitude. You can see here signal A, signal B, they combine together, A plus B, beat interference. All right. Molecules in the air vibrates about some average position, creating the compression and reflection. We call this frequency the pitch. Sometimes we
say like this sound because of the sound wave.
Sometimes the sound changes like this.
Sometimes the sound chamber like this. All these are basic.
Considered as the vibration depending on
fast or how slow it vibrates. All right. So this frequency of sound, as demonstrated just now through the different pitch, is called frequency of sound, known as the pitch. All right. So as mentioned earlier, sound travel at a speed of 330 meters per second. Lightning travels much faster than sound of thunder. So a 3-second gap between the flash of lightning and the sound of thunder means that the storm is about a kilometer away. All right. So back to this. The speed of sound depends upon the temperature of the air. Sound travels faster through the hot air, but slower through the cold air. All right. The speed of sound does not depend upon the pressure of the air. If the atmospheric pressure changes, speed does not. The speed of sound is different through different materials, faster through solid, then liquid, and then gas. So these three boxes basically summarize what is the speed of sound about. All right, so you can see that the air, dry, these are the respective speeds of the different solid, liquid, and gas. All right, next. How can we calculate the speed of sound in air? We use the formula called speed equals to distance over time. Let's say, for example, now I'm standing 75 meters away from the brick walls, and I start to clap my hands. The sound wave will travel from my hands all the way to the brick and bounce back off to where I am standing or clapping. So with that, the speed of the sound, the distance is 150. Because the speed of sound in the air is 333 meter per second, therefore the timing taken to travel will be 0.45. So we use the speed equals to distance over time as the formula to calculate the speed of sound in air. Next, are the particles needed for sound to travel? Well, you watch a movie called Alien, right? I believe there's a lot of movies in the world out there talking about aliens, Star Wars, or different fantasy things. You hear all the plane actually they zooming down the outer space, zooming through the outer space, all the sound, all these things. Well, all these are only effects for the movie. In actual fact, no sound can travel in space. Definitely, you need particles because you need medium for the sound to travel. So, will sound travel faster through a solid, liquid, or gas? Yes, sound travel faster through a solid because the particles are more densely packed together. All right. An echo is a reflected sound waves. All right. We use echo to determine the for the ship to determine the navigation as well as the depth of the water below the sea. So there's a transmitter at the bottom of the ship where you will send an echo down and it will pick up the echo that's back to the ship. All right, so basically telling you how much water depth is the current water level. All right. So a boat sent out a sound wave so that the captain can calculate the depth of water. The captain knows that the speed of sound in water is 1,500 meter per second. So distance equal to speed times time. But don't forget that the sound has traveled there and back. So we need to divide our answer by 2 to get the depth. So if you are a captain of a ship, you have to use this formula, distance equal to speed times. So based on the timing they come back, you have to times the water speed is 1,005. From there, you will get the distance, but you have to divide by 2 because the sound travel 1 and 2. Therefore, you need to divide by 2 to get the water depth level. All right. So calculate the depth if the water is the time taken is 0.2, 1.1, 0.5, 1.6, or 2.1 or 0.8. So this one you can do it at your own timing. Not worry, no issues about that. Let's carry on. So as mentioned earlier, the water depth, to calculate water depth, we have to use speed times time divided by 2. So the speed is always constant, 1,005 in water. So times 0.2, you get 300. But 300 is the to and fro of the sound wave. Therefore, the divided by 2 equals to 150. And so on and so forth. All right. Next. When do we use sound? How can we use sound in the daily lives? Well, we have this thing called the radar. Radar is used to detect object, all right, like the aircraft, or I'm sure you all play game, right? Like the enemies at which corner here and there. So radar use sound to detect object. Then we have sonar, whereby sonar is used to detect object underwater like submarine. All right. Next, loudspeakers converts the signal from the signal generator into sound wave. So this is called a seeing the sound method, whereby a signal generator will produce signal over a range of frequency where it will be transferred to the respective sound loudspeaker, which then convert into sound wave for us to hear. All right. The shorter the wavelength of the waves, is the higher the frequency of the sound. So in this picture here, you can see that the wavelength is very short. Respective wavelengths are very packed with each other. So this is called the high pitch sound. So all these high pitched things, right, will basically means right, the sound wave is very packed. But for this is very low, so very slow and low. So this is a low pitch sound waves. All right. So a high pitch sound, a low pitch sound. And as mentioned earlier, the shorter the wavelength of the waves or the trace, the higher the frequency of the sound. The more waves you see means the higher the pitch. So students, for this chapter of sound, to learn about sound wave, the more waves you can see, the higher the pitch of frequency. All right. Next, what about the quiet and the loud noise? Just now we talked about high pitch and low pitch. Now, how do we know which wavelength is quiet sound or loud sound? Well, we look at the height of the sound wave. This first picture here, the sound wave is only 1 bar. This means a quiet sound. A quiet sound, very, very low sound. It's like whispering. You can't really hear. So it's like whisper. When you whisper to someone, your sound wavelength is like this. All right. As for this, is high because it's more than 1 bar. It's higher than this. So this is a loud sound. So this is a quiet sound and a loud sound. The larger the amplitude of the waves on the trace, the louder the sound. The bigger, so in summary, the bigger wave you see, the louder the sound. All right, or the more wave you see, the higher pitch or frequency. All right. So what is our range of hearing? Which type of sound we can't hear? Which type of sound we can hear? For we humans, we can only hear a minimum of 20 hertz, maximum of 20,000 hertz. Anything beyond that, we won't be able to hear. All right. For the bat can hear minimum 1,000 hertz, maximum of 120,000 hertz. All right. Next, we have dolphin. Dolphin minimum can hear a sound wave of 150 hertz to the maximum of 150,000 hertz. A dog, minimum of 15 hertz, maximum of 50,000 hertz. All right. Cat. A cat is 60 hertz minimum, maximum is 65,000 hertz. So we humans invented an ultrasonic cat scarer to scare the cats. So basically, they use the ultrasonic cat scarer, which is 20,000 hertz to 30,000 hertz, to scare the cat. It's quite loud for that. All right, next, ultrasound. Everyone in the family, when they have children or when they are pregnant or when they are doing another scan, they'll be using ultrasound. Ultrasound is any sound above the range of human hearing, above 20,000 hertz. It can be used as industrial cleaning, such as cleaning of circuit board or the teeth. All right, breaking down the kidney stone, or industrial quality control to determine any cracks in the metal. Lastly, I'm sure you guys are familiar with this picture, prenatal scanning of the fetus, and range of direction finding, sonar. All these that I mentioned on the slide uses ultrasound. All right. So all these things are quite useful for you to learn. So all you do one thing is whereby the maximum hearing and minimum hearing of human is 20 hertz to 20,000 hertz. And then for the bigger wavelength, you see, the louder the sound. And then we have the more wave you see, the higher pitch and frequency. All right. With that, I have ended my lesson for today. We shall now proceed with the quiz. All right. So let me just open up the quiz now. All right. So okay, let me just open the quiz now. So one moment, give me 5 minutes. All right. Alice, do you want to open the quiz?
Can you do it? I don't. My internet is
I might need your account.
Oh.
Maybe you can let's share with me your account in the
Yeah,
Zalo.
yeah.
All right, one moment, please, while we settle some technical issues. All right. Okay, I think I saw your account already. You have sent me before. Let me just log in first. One moment. Let me share the screen now. All right, Alice, which one is the...
You click the with my sets.
Or
My
sets? Okay.
sets.
Oh, my sets. Okay.
And then down.
All right. Saw it.
Yeah.
I press host, right?
Yeah, that's right.
All right, students. Okay. Which one do you prefer? You prefer crypto hack or monsters or anyone? All right. Let's choose monster then. All right. Monster bow, right?
Yeah.
All right. So what should I? So as a host, I press host now. Okay. Let's wait for it to load. I will give 5 minutes then. Okay, I shall host now. Alright, students, if you are okay, you can join the link in the chat that I just sent out. Alright, as mentioned earlier, for the sound wavelength, the bigger wavelength you see means the louder the sound. Alright. As for the higher pitch and low pitch, the more wavelength you see means the higher pitch or higher frequency of the sound. Alright. We know that the formula of the sound is distance equals to speed times time, but that only applies to through the air. We are talking about the boat in the water. You have to do speed times time divided by 2, because you have to make sure that you have to count the distance to and fro. Right? Sound cannot travel through space. The average speed of the sound is 330 meters per second in the air. Alright? There are 2 types of sound waves. Sorry, no, there are 2 types of waves. One is longitudinal and transverse. Alright? Sound is produced through the vibration. So once you remember all these concepts, I'm sure that this quiz will be very easy for you all. The most important of all is the speed of a sound is depending on the temperature, as well as depends on the different material used. Alright? Okay, I shall start then. Last 1 minute. All right, last 30 seconds. If Alice has 400 plus now, then followed by James 247. Right, then we have Alex is 187 currently. All right, last 5 seconds. 5, 4, 3, 2, 1. All right, that's it. Let's clap for Alex, James, and Alice. All right. Okay. So thank you very much for this. All right. So with that, right, we have come to the end of the lesson. It's quite early, I understand, but I think we go through too fast. It's been 1 year. We have revised through living things and non-living things, the 5 animal kingdoms, plants, non-living things, materials, systems, body systems, plant systems, light, energy, forces. We talk about matters. We talk about the solar system. We talk about sound. We talk about basically quite a number of topics. So I will consolidate the list of the slides that was teach for the past 1 year to the group by this week, so that at least you guys have the materials to learn and revise after the sessions. All right. So it's 7:33 p.m. in Vietnam, 8:33 p.m. in Singapore. Madam, back to you. Sorry that's quite early today.
Oh,
Yeah, today is quite early.
so the class finished?
Yeah, quite early today.
Oh, okay. All right. So
Yeah.
on behalf of nhịp cầu sinh ngữ, the language bridge network, thank you very much. Really sincere. Appreciate your time and efforts to run the course in over a year so far. If I remember, it was like beginning of November, correct? When we started?
Yeah, correct. That was the last year, end of October.
Yeah,
around there.
yeah.
Yeah.
So I believe that, you know, this after a year, the student have learned a lot of not only science knowledge, but also their English, you know, their English level is also enhancing, increasing, right, by learning directly from you in English, right? So sincerely thank you. I
Yeah, thank you
guess
very
the
much.
children here, they're quite young. Probably they don't have Facebook, but let's open the, you know, let's allow them to unmute themselves, right?
Yeah,
So
sure.
all the students, feel free to express what you think about the course and to express your appreciation to teacher Andrew. Right, maybe I invite Alice and Minh Anh start first. They are
Right,
our
thanks.
lovely co-hosts.
Yes,
Yeah,
yes,
and
thanks.
then right, Minh Anh or Alice, who first?
Can I go first?
Sure.
Thank you, Teacher Andrew, so much for the useful course. And my science skills also improved very much after your two courses. One is for beginners and one is advanced. And I hope in the future, sorry, wait me 1 second. I hope in the future you can come back to Nico School and teach us another course. And also thank you to your wife, which watched your babies while you were teaching, so you don't get distracted from them. And thank you very much again. Thank you very much for your useful course and your time. Yeah, thank you.
Thank you, Alice.
Um, Thank you, Teacher Andrew, because for like the last 1 year, I joined a bit late, but I do enhance my science knowledge because you help me revise and yeah, and spend your time because I think sometimes you ate dinner a bit late. I I really thank you. Thank you,
Thank you
teacher.
very much. Thank you, Yan.
All right. So James, James.
Yes.
Okay. Would you like something to Teacher Andrew?
No, I have not.
Oh, come on. Say a few words. Thank you, Teacher Andrew. I know you can do it. Say how much you love the course. All right. You say just, say thank you and then, explain how much you love the course. James. Short one, okay. Few words.
I'm thank you, Lynn and Real, because I learn science, but I am sponge English, but I learn English at my aunt.
Understand. Thanks a lot. Thank you very much. All right.
All right. Well done, James. Thank you. Now, let's see. Bích Ngọc. Would you please say thank you, Teacher Andrew, and explain how much you love the course? Bích Ngọc. That's too shy. Yeah. Okay.
Thank you, teacher,
Yes.
so much. Thank you, teacher, so much.
You.
All right. Thank you very much.
Yeah.
Okay, so I hope to see you guys again. Once I settle down the school work, because a change of school position, if more responsibility in the school. So therefore, I have a little time to do this course. I hope that once I stabilize down, I can manage to find another course to teach at NCSN.
Okay. Yeah.
All right, so thank you very much, and hope to see you again. Thank you very much.
All right. Thank you, Teacher Andrew.
Bye.
Really
Take care.
appreciate. Yeah. Thank you to your wife, Miss Phụng Hoàng. All right.
Yeah,
I
thank you
know
very much.
that she's the person she's the boss.
She's the boss. Yes, she's the boss.
Yes. All right.
The
So
lady,
thank you.
the Vietnam lady is always the boss.
All right.
All right, thank you
Yeah,
very much.
we really appreciate both of you. Thank you.
Right.
Yeah.
Right.
All right. Hope
That's all.
we can have another course probably in the early of 2023.
Hopefully.
Yeah.
Right. Yeah, thanks a lot. Thank you very much. Thank you. I shall make a move first. Because
Yeah.
Thank you very much. Bye bye.
All right. Bye bye. Take
Bye.
care.
Okay.
Teacher.
Bye. Thanks for your
Thank you.
Cảm
Bye,
ơn
teacher.
Alice,
Thank you for your
cảm
time.
ơn Minh Anh nha. Hai bạn nhỏ đã đồng hành với lớp, đã làm cầu host, Alice và Minh Anh, và còn lại backup giúp cho Teacher Andrew những buổi mà thầy không có dạy thì hai bạn lên để sửa bài để cho các bạn làm quiz ha. Cô Đức thay mặt tất cả các bạn cảm ơn Minh Anh và cảm ơn Alice. Cảm ơn Alice làm look at và làm quizzes nữa nha. Rồi, hy vọng là tụi con đã tìm được những cái buổi học rất là lý thú và học được nhiều kiến thức bổ ích, đúng không? Mình thầy bận nên khóa mình tạm dừng ở đây. Sau như thầy nói á, thì sau này khi mà thầy sắp xếp được công việc mới thì thầy sẽ quay trở lại nha. Rồi, cô Đức chào tất cả các con. Bye. Các bạn nhờ bố mẹ lên Facebook gửi lời cảm ơn giùm cô Đức nha. Tại vì những lời cảm ơn như vậy là tạo động lực cho thầy Andrew để thầy dạy khóa mới cho tụi con nha. Nếu mà tụi con có Facebook thì lên cảm ơn trực tiếp. Còn nếu không có Facebook thì tụi con nhờ ba mẹ viết giùm nha. Được không nè? Cô Đức xin 20 bạn ở đây là 20 lời cảm ơn nha. Hứa không? Hứa với cô nhé. Một lời cảm ơn đâu có mất bao nhiêu thời gian của ba mẹ, đúng không? Nhưng mà lại tạo cái động lực và có cái ý nghĩa rất là lớn đối với giáo viên tình nguyện. Vì giáo viên tình nguyện dạy tụi con phải bỏ còn nhiều công sức nè, mà thực ra là không được nhận gì hết ngoài những lời cảm ơn của tụi con nha. Rồi, cô Đức chào, bye bye. Nha.
Cô Đức ơi, cô Đức, Doctor viết tắt, nhưng mà con biết là Doctor này nè, Doctor hay viết tắt đấy có nghĩa là tiến sĩ.
Rồi cô biết rồi, ok. Nhớ nha, con nhớ nha. Lên Facebook cảm ơn thầy nhé. Ok.
Yeah. Nhưng mà con đã copy rồi, giờ con gửi.
Rồi, cô dừng ở đây nha, bye bye.
Thưa cô Đức, làm phụ huynh cảm ơn ở trong cái group Facebook mà bài cô đăng đây phải không ạ?
Dạ vâng, dạ đúng rồi. Có
Vâng.
Đức vừa mới gửi đó. Dạ.
Vâng,
Nhờ phụ
vâng.
huynh nhờ phụ huynh nha. Nhờ phụ huynh lên cái gửi. Phụ huynh cứ viết tiếng Việt cũng được. Thầy sẽ đọc và dịch ra cho thầy.
Vâng, cảm ơn cô Đức rất nhiều ạ. Cảm ơn.
Dạ.
Vâng.
Để Đức xem coi nó có Đức có mở khóa Zalo. Để Đức có gì chắc là Đức mở Zalo cho mọi người nhắn tin gửi cảm ơn hôm nay nha. Rồi, mình chào nhé. Cô dừng nha. Rồi.
Cô em đi cô.
Cô để cho các bạn ra đã rồi cô. Rồi để cô mở Zalo cho mọi người. Mở ra cô cứ sợ quảng cáo thôi. Rồi cô mở. Rồi tụi con rời đi. Thế rồi, hết giờ học rồi. Cô mở Zalo thôi.
Dạ. Chào cô.
Bye ha. Chào cô em nha. Bye bye.